Hey kids, today we're going to look at the last part of this lesson, and this is again about soil formation. And today we're going to look at the properties of soil, like what are different ways to describe the soil or different things about it. So hopefully if I hit that, there we go. All right. Soil properties, some of the ones that are most common are texture, which we talked about that with rocks, how it feels, the color, the chemistry, which we'll get to later, pore space, which I'll explain later, and what's called fertility, which means how crops or vegetation grows. Oops. Okay, so here's the first thing we need to know. Soil texture is a property that describes the relative amounts of differently sized soil particles. So there's three main ones we're going to learn today: sand, silt, or clay. Okay, and the texture describes how many of all of those there are. Oops. Okay, wherever I put the picture, it's in the wrong spot. Soils are a mixture of all three of these. Sand is the largest. So if you look down here, this is not true at all, but compared, sand is the biggest, and then silt, and then clay. So if you would to color these in, you would see that then silt is medium sized and clay is the smallest. Sand, if you've ever been to a beach, or I'm sure you know what sand is or feels like, then silt is a little smaller, and then clay. All right, soil can be a variety of colors when you describe it: black, brown, red, orange, yellow, white, depending on, again, what it's made of. Soil color is a great clue as to what makes it up, as to the minerals and the organic matter. So temperate soils, which means the climate's a little warmer, some water, some rain, not a ton, are the most effective for crop growth. Okay, so here are four different types of soils. First of all, there's tropical, which would form in warm, wet regions. Can you think of somewhere like that? Well, in the United States, I would think of like Florida, Florida being probably the most, southern Alabama, southern Mississippi. Okay, so they have heavy rains, which leaches the soil, meaning kind of erodes it away. So there's only a thin layer of humus. Takes the soil longer to develop there, and a lot of crops don't grow there. Then we have desert soils, where I'll be going next week for a couple days, like out in Arizona, New Mexico, parts of Nevada. Again, they are shallow. They have little organic matter because there's not a lot living there. Hardly any rainfall. So there's not a lot of weathering, and soil development is very slow in the desert. Then there's temperate, which would be us. All of the Midwest, Indiana, Illinois, Iowa, all of those big farm growing states, crop growing states. Okay. So moderate rainfall, so some, not a lot. Moderate temperatures, yes, it gets cold, but it gets warm, but generally it's kind of in the middle. They are dark colored, rich in organic matter and minerals. There we go. Couldn't say it for a second. And then last, from like the way up north, Alaska, Montana, southern Minnesota, or northern Minnesota, I'm sorry, form in real cold, dry regions. Not a lot of chemical weathering, not many horizons, those type things. All right. This is a new term that you'll get into later in your science career, but you might hear the term pH, which is potential hydrogen. And that is determined by the number of minerals, the sediment that's in the soil, and the organic matter. Okay, so it tells how acidic, how much acid there is, or what's called basic, which means kind of just the word they use is base. Okay. And the scale goes from 0 to 14. And so you know, as a point of reference, water's right in the middle. Water is a 7. So if you see a pH number of less than 7, okay, then that is called acidic. It's got a lot of acids in it. If it's greater than 7, then that's called a base or basic. So here is a good chart. So here is 7, all right? And as you go up, it has more acids. So if you think of like orange juice, it's kind of acidy or stomach acid, or of course, battery acid, okay? That would have a lot of acid in it. But as you get lower, then there's like bleach, and that's the opposite way, or soapy water. Those are what's called bases. All right. So a lot of times farmers will add lime to make soils more acidic or basic, depending on what they can add, what they need their soil to be. Okay, so if you look at this picture, you can see that the pH of 7, the crops are growing much more than when it has too much acid in the soil. Not growing near as much there. Okay, so as it says, this is why appropriate pH levels in the soil are so important. All right, next term we need to know is what's called pore space. Okay, and that describes the spaces in between the particles where water and air can get down into. So if they're well connected, the pore spaces are connected, it's best for plant growth because it allows some water to move and air to move freely through the soil. Okay, so the best soils for growing plants, which is what we care about as here in Central Ohio as farmers are getting ready to plant here in the next couple months, is if it had 50% of volume as pore space, okay, and then have them evenly distributed, okay? So if you look at these pictures, you can see where the air is, where the water, and where the soil would be. All right, so we have this with a lot of pore space, nothing in between, and this with lots of smaller rock fragments in there. So let's talk about how we could describe these pore spaces. Well, this one has very good pore space. You see all the space for room for, air and water. And then that one has very little pore space. There's not much room for things to get through. All right, the last thing how we classify soils is called soil fertility. And that talks about how well soil can support plant growth. And to me, this is probably the most important one, at least around here. Okay, so it is affected by the climate. Again, the best is like a temperate climate like we have. The amount of humus, meaning the amount of living organic matter, the minerals, the nutrients in the soil, and the topography. We talked about that yesterday. That's how flat or hilly or mountainous the land is. Okay, the most fertile soils, those that grow the most plants, are the temperate soils. Again, that's what we have, are found in areas with moderate rainfall, so kind of Goldilocks, just the right amount, and the right temperatures. Again, yes, it does get cold, and it gets hot in the summer, but in general, it's right in the middle, okay? Soils with a lot of humus also help, okay? So that means living things, it's kind of a circle, because if the living things are there, then they can grow easier, then ultimately they die, and it just circles around. All right. Fertility, obviously, as our farmers know around here, they add chemical fertilizers, organic material, which could be a variety of things, and adding different crops. Farmers around here will plant like corn one year and beans the next because it changes up the fertility. All right, so real quickly here, what could you do to improve the fertility of the soil in your garden if you have one at home? Well, you can add other organic materials or plants to restore nutrients. All right. So let's look at soil A and soil B and figure out why they are what they are. So soil A is black, well-drained, and good for growing plants. What are some reasons? Well, Probably has lots of humus because it's dark black. Okay, so living things have organic matter has been there. In the A horizon, because that's the top most horizon, probably well-connected pore spaces so the water and the air can filter through, and probably has high fertility, grows a lot of crops. B is smooth and sticky and gray. Well, it's probably clay. Clay tends to be more gray. And probably not much sand because it's smooth and sticky. You know how sand feels, not smooth or sticky. Probably not drained very well, and it's probably in a wet environment. All right, we will stop there. Again, please, hopefully you've watched this and then answer the questions. And of course, you may redo those if you need to. All right, have a good one.